We're continuing on with the notes today. I did not finish with the other hour so far, and most likely we're not going to finish the notes today either. We'll finish them up tomorrow, and then you'll have time in class to work on the assignment. Now, this here is not in the note sheets. I realized this earlier today. I don't know what it is with section 1.1's notes. Hopefully next year I will have them more in order than I do this year. But so you can flip it to the back if the back of the homework sheet is completely blank, so you can put some notes in there. But for the most part, this first part, writing interval notation, isn't something I would consider or say is completely new. You've done interval notation in Algebra 1. We didn't talk about it much in geometry. It's using our parentheses and brackets, talking about an interval. We have normally two numbers in there, or a number in infinity is our interval notation. Now our parentheses is not included. It's not equal to. We put parentheses around infinity, negative infinity. It's not included. That number is not included. Our brackets is included, or it's equal to it. Because if it is equal to that number, we put a bracket. If it's not equal to it, we put a parenthesis. And infinity and negative infinity will always have parentheses. So if we look at this first one here, we have the interval, or so our inequality, negative 2 is less than or equal to x, is less than or equal to 3. Now for some, in some of the other hours, it was easier to first look at the graph of it, if we graphed it, and then turned it into interval notation. Now this is what we call bounded because it has two numbers. And our two numbers are negative 2 and 3. At negative 2 and 3, we will have two circles. But the question is are they going to be opened or closed? So these 2 points, will they be opened or closed? Because yes, if it is not equal to it, then they would indeed be open. So are they equal to it at either one here? Because what is this symbol representing? Because we have greater than, less than, greater than or equal to, or less than or equal to. So this here would be what? Anybody know? Less than or equal to. And because it is equal to, it has the equal to part, this would be closed. It would be included. And 3 is also included because it is equal to. Because if we have that line underneath the inequality sign, it is equal to. So it would be included. And if the variable is in the middle, we shade the middle. So this here would be the graphical representation of it. So what we want is the interval. So we're going to be using our parentheses and brackets. Now we list the two endpoints, or infinity if it continues on in one direction or the other. So here we have two endpoints. The first number we're going to have is the smaller of the two. And the other number we'll have is the bigger of the two. But we need to include our parentheses or brackets. Now because both points are included, we would use brackets. So we'd have negative 2, bracket negative 2, comma 3, bracket, because both negative 2 and 3 are included. Any questions on any of this here so far? We're ready for the next one. So again, for B, the first thing we'll do is graph it because it's a little bit easier to see the graph and go from there. So if we were to graph this here, our main number that we have is negative 1. Are we given a second number? No. So that means it's going to go to infinity or negative infinity. It's going to go to one or the other. So is it going to go to the right or to the left? Is it bigger than -1 or less than -1? Bigger, so it would go to the right, because it would be all the values of x that are bigger than -1. Now, do we leave it open or do we fill it in? Do we have the equal sign? No. No, you're good. Because that's one of the key things to look for here is this here with these inequality signs will tell us if it's equal to or not. Because if we do have that one equal sign underneath, we fill it in. If we don't, it's open. If it has the bracket, if it has one of our brackets, then we fill it in, or we have our equal to sign. If we don't, if we have a parentheses, it's just going to be greater than or less than. So this is our graph. Now we need to do our interval. We need to set the interval notation. So we know one of these points is -1. Is this the biggest value we can have or the smallest? Smallest, because it's the first and then it goes bigger, yes? So the smallest, it'll go first. And then what's our biggest number going to be? Our biggest number would be infinity. Because one of these here, when we just have that unbounded is going one direction or the other, we're going to have infinity or negative infinity, one or the other. And as we said already, is -1 included? Well, no, so we have a parenthesis. Will we use a parenthesis or bracket next to infinity? Because can we ever get to infinity? Can we ever reach infinity? No. Because we had the hotel that we talked about the other day, where we can always make one bigger. We can never get to infinity. So it's always going to have a parenthesis. Even if it's negative infinity, it will have a parenthesis. Questions on these two here? We good with these here? Let's look at the next one. The next one, do we have two definite endpoints? Well, yeah. This C is just like A. We have two definite endpoints, two spots where it stops. Are both of the endpoints filled in? No. One of them's open, one of them's closed. At -3, it is closed, so it is included, yes? Is 4 included? No, because it's open. So if we write this as an interval, we would have our two endpoints, -3 and 4. Now, will the -3 have a parenthesis or a bracket? Because if it's included, it is a bracket. If it's not, it is a parenthesis. So -3 would have a bracket, and 4 would have a parenthesis. Questions on any of this so far? I think most of this should, does it start to seem a little familiar? From probably Miss Kendall's class, if you had her, or your Algebra 1 teacher, covered it some. It's probably been at least 2 years since y'all had to do this. Let's look at the next one. Do we have two definite endpoints? No. We only have one, and the one endpoint we have is 3, okay? Is it heading to positive or negative infinity? Negative infinity. So for our two numbers for this, the smaller would be what? 3 or negative infinity? Which one's smaller? Negative infinity, yes, because it's just a negative of a really big number. And we always put the smaller number first and the bigger number second. So whenever we list them out, especially on those intervals, smaller number goes first, bigger number goes second. And we could have multiple of them. And then what symbol goes next to negative infinity? And how about 3? Bracket. Questions on this here? And we'll do some more of these later, especially with interval notation and graphing. Any questions on these so far? Okay. On that back sheet of paper where you've been writing, we do have one last thing I want to look at with it. It's something called set builder notation, and that's what we'll be mainly looking at for the next few problems, is set builder. You know, I don't know why these 2 pages got completely removed from the note sheet, but I'll definitely need to fix that. Now, this is an example of set builder notation. Set builder notation will always have 2 braces, one to start and one to finish it. So these 2 braces here will always be included whenever we write in set builder notation. I don't know how that happened. So whenever we write in set builder notation, we'll always have that. These will always be listed in set builder notation. Now the first part of this is this x here. This x, this part of it describes what kind of numbers we're talking about. So if you remember back to yesterday where we talked about natural numbers, whole numbers, integers, rational, irrational, real numbers, that's what goes here. And unless it's told us otherwise, we're going to be using real numbers. Unless it specifically says the set of all integers or the set of all rational numbers, we're going to be using real numbers. And all we have to do is put x here. You just have to put an x if it's talking about the real numbers. If it's talking about another number group, we can change it here or somewhere else. It'll make more sense, especially when we do an example. And then we have such that, this bar. This bar is another key piece that will always be there. Will always be the same every single time. So we have the braces that will always show up to start and finish. We will have that bar to split the 2 from the types of numbers we're talking about. And the last piece here is the description. Describing kind of some information about what kind of numbers we're talking about. So for here, x is greater than or less than b, whatever value b is. So we could say 4, so x is less than 4. Or x is all the numbers greater than 4. It tells us and gives us a description of what kind of numbers we're looking at. And we do have these examples here, but let's go on and look at our first one here. We'll have to skip a page or 2 because we're looking at this one here, because this is actually in the notes. So I think it's the back of the first page, actually. So when we write something in set builder notation, I think it's going to be best to first identify our different parts, what we're talking about. So this first one that it wants us to write in set builder notation is the set of all integers greater than 5. Did it specifically tell us what type of numbers we're working with? Because the integers, we're talking about integers, which is our positive and negative counting numbers. So we're not talking about decimals, fractions, irrational numbers. So we have those there. So it told us the type of numbers that we have. Then it gave us a description, yes? They are greater than 5. Now for the integers, we had a symbol yesterday that defined integers, which is a z with an additional line. So this is a way to say integers, the symbol to represent integers. Now, greater than 5, as an inequality, we would say what? X is greater than 5. Now when we use set builder notation, I will specify that we really have to have it always in in inequality notation. If it's written in interval notation, like part B on this here, we have to change it into an inequality. If it's already written in an inequality, we don't have to do anything to it. But before we write this in set builder notation, are there any questions? Any questions on how we found any of this so far? Okay. Now the first part of writing this in set builder notation is our brace. So we start with the brace. Then we have x. Now we would draw the bar, especially if we were talking about all real numbers, but here we're talking about integers. Now I'm going to introduce a new little symbol for you, because whenever we talk about integers or any other number, we use this little e. This e is an element. So we're saying x is an element of the integers such that. So in most cases, when we have real numbers, we don't have to include it. It's just understood. But if it's a part of another number system, we'll do x, our e, and then its symbol. Questions on any of this so far? It's so we're adding the e. So the main reason we add this e, that's the main question, is why we have this here. And that's to signify that it's not just a part of the real numbers. Because if we don't include this here, and there's another way to write it without it, if we just do brace x bar, this says the set of all real numbers x. But we're not talking about all the real numbers, we're just talking about the integers. So the other way to do this, instead of saying x is an element of the integers such that, give our description, we can do this here, which says the set of all real numbers x such that x is an integer. So we can specifically write that in. And we'll need and in our description. Any other questions before we finish this up? Now, what was our description of this here? Our description was what? X is greater than 5. So in both places, we can finish it by saying x is greater than 5. And that's it. Both of these are saying the same thing. One of them is just a little more condensed than the other. Any question on either one of these here? We good with these two here? Or, well, this one, we haven't done two yet. Now the second one. Negative infinity, comma, -1, or -1 to infinity. So it's written in interval notation. We need to change it to inequalities. We need to rewrite it as an inequality. Now, I'm going to first graph these on a number line and then write it as an inequality, because I found for some it's easier to write the inequality based off the graph than it is from just a interval. But if you can see or write the interval, not the interval, but the inequality from this interval, that's fine too. Because if we look at negative infinity to -1, of these two here, which number can I actually put on a number line? -1. we can't really list negative infinity because it's not an actual number, it's a concept, but we do have negative 1, and we have a circle for it. Now, is the point at negative 1 going to be opened or closed? Because is parentheses included or not? It would be open. Because I ran right over the top of your answer. But yeah, it would be open because parentheses is not included, which is open. Bracket is included, which would be closed. So this would be indeed open. Now, are we going to shade to the left or to the right? Because which direction is negative infinity? Is it bigger or smaller than negative 1? Smaller, so which direction would we go? Left. Because which direction are the smaller values? To the left. So we're saying this direction here, yes? So if we wrote this as an inequality, so x and negative 1, is the values of x going to be greater than negative 1 or less than it? It would be less than, because we're going to the left. Or negative 1 to infinity. So again, I'm going to graph it. Our main point is negative 1. Now, will this one be opened or closed? Open, because again, we have a parenthesis. Now, this time, are we going to shade to the right or to the left? To the right, because infinity, positive infinity, would be bigger than negative 1. And we would go to the right. X is going to be what? Greater than. Any questions on how we wrote this inequality statement? Are we ready to write it in set builder notation? So the first thing we start off with set builder notation is our brace. Did it tell us what type of numbers we're working with? Not specifically, did it? If it doesn't specifically tell us, or especially with interval or inequalities, it's understood to be all real numbers. So since it is all real numbers, these are the nice ones. We can just do x bar, because it's understood to be the set of all real numbers such that we fill in the blank. Because if we're given an interval, we're given this to start with or these to start with, and there is nothing telling us what type of numbers, this is how we're always going to start it. Brace x bar. Ready for the next part, the tricky part. What is our description? Well, this here, yes? Fill it in. And that's it. So these are very nice, especially if they give us it in inequality notation already. Because if it's already written as an inequality, we just describe what type, especially if it doesn't tell us anything. Brace x bar, fill in the inequality. Questions on this so far? For the most part, it's getting used to writing as this kind of form because it's new, but also just changing it into inequality notation. Change it into an inequality, because once we got that, we can fill it in. Do we want to see one more go into inequalities and then to our set builder? Because we do have one more. This one here. So we can look at the first part here. So I'm going to graph it first so we can see it graphically. That way when we change it to an inequality, it might be a little bit easier. So can we graph negative infinity on a number line? Can we graph negative 1? Yeah, negative 1. And this time the circle is going to be opened, yes? Because? At the bracket, yes. So this is going to be closed. We'll fill it in. Now are we going to shade to the left or to the right? Left because it is negative infinity. It is less than it, yes? So here we're saying what? X is less than negative 1, yes? Is it missing anything? Because we used the same symbol on the last one, yes? When it wasn't equal to it. We need the line underneath it to signify that it is indeed equal to it. Because if it's filled in, we do need that little line underneath to signify that it is equal to it. Or, because when it has that or statement, we just bring it down with it. 1 to infinity. Well, the only number that we can actually graph on this is 1. And this one, like the other one, is filled in, yes? It's open because we have a parenthesis. Now, do we shade to the left or to the right? To the right, because we're going from 1 to positive infinity. It's going to be all the numbers bigger than it. So we get this here. So x would be what? Greater than or equal to, or just greater than? Just greater than. Because we would need the equal to if it was closed. Questions on how we got to this here? We're still talking about all real numbers, yes? So when we write the set builder notation, we're just going to start out with brace x bar, yes? Then what are we going to have next? This whole thing. X is less than or equal to negative 1, or x is greater than. That's it. We ready for the next one? This one here, except for the integers, because it says the set of all integers except for negative 4, I think this is one of the ones that y'all are going to like more than some of the others. Because the first part of the sentence that we can see is it's talking about integers, except negative 4. So we can have anything except for negative 4, yes? Which means x cannot be what? Negative 4. It can't equal it, yes? What's a way that we can write not equals as a symbol? So if I said x is equal to 4, we would say what? X, then put in equal sign, negative 4, yes? How can I change this to say, put a line through it? Yes. Because any time we talk about not equals or not greater than or not one of those, we can put a line through it. So this is saying that x is not equal to negative 4, yes? Well, that's really all we need. Because we can say brace x. We can use our funny looking e, because it's almost like an e but a little bit elongated, is an element of the integers. Do we remember the sign for integers? Z is an element of the integers, such that what? X is not equal to 4. That's it. It's even nicer if it said the set of all real numbers except -4. If it said that, instead of integers, it said all real numbers. Well, we just dropped the E and Z and have this. That kind of makes sense. That one's kind of nice, especially just not that number. It's everything except that number. Questions on this here? Well, like this entire section's been, we are going to the next part. It's not jumping around, but the notes technically are kind of jumping around. The next sections won't do that as much within the notes themselves and the content of the notes. I will make sure of it. Now, subsets, listing them out. If we can write them out, we are going to write them out. If we can't, then we're going to have to use an inequality or an interval notation. Because if I think of the whole numbers are our counting numbers and 0, yes? So can we list all the numbers from 50 to 54? So what's the first number? 50. And we put a brace, so we'd have 50. What's the next one? Well, 50 and 52, 53, and then 54. We're able to list all of them, yes? So there we go. We've listed them all. Now, if it had said all the whole numbers greater than 50, greater than or equal to 50, well, we'd have 51, 52, 53. We'd have this here, yes? But if we're just talking about greater than it, does it stop at 54? It keeps going on, yes? And a way that we can show that it continues on in this pattern is our ... Because I think we talked about that a little yesterday, yes? Now, if it did have a definite endpoint, but it was excessively far away, it said from the whole numbers from 50 through 1,000, we can do a ... and then put 1,000, saying that it's going to continue on like that till 1,000. Does that make sense? All right. Any other questions or any questions with this? This is kind of nice. All right. The real numbers, 0 through 4. So what's the first number that we can have in this list from 0 to 4? 0. What's the next one? Right? How about a half? So half would be considered a real number, yes? Because it's part of our rational numbers, which is a real number. So a half works, yes? So we'd have to list that. How about a third? A fourth? A ninth? 2 sevenths? 0.24? 0.39? Is there any way that we can list all these? Because we can think from 0 going, well, let's just start at 1. From 1 going out to infinity, we have all those numbers, yes? And can't I put 1 over whatever that number is, yes? 1 over 1 is 1. But then we also have 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 6, 1 over 7. Well, I can go all the way to infinity doing that, yes? And then I can do, say, 2 over 3, 2 over 4, 2 over 5, 2 over 6, 2 over 7, and go to infinity there, yes? Wait a minute. We haven't even made it past 1 technically, right? Because especially if we start with 1 over 2 and continue on from there, I just put 2 different types of infinity between what? 0 and 1. We can't, I mean, we could if we could make a pattern, but there's not a decent pattern for this. I mean, it works for this here for rationals. Then we also have our irrationals, so the square root of 2 and the square root of 3. And my main point is there any way to actually write these out? No. So we go to an inequality. Because an inequality is saying it's all the numbers between those 2 spots. That's why they're nice. So what we could say is, well, one of our numbers is 0 and the other is 4, yes? So 0 is less than whatever number we're talking about. It needs to be less than 4. And realistically, we would need to do it more in set builder notation. But for our case and purpose, this is what we can call it here, because the number of numbers between 0 and 1, for all case and purpose, is infinite. We can make an infinite number of numbers between those two just by doing our different fractions. So there's no real way for us to systematically list it, let alone the irrational numbers that also take place between those two. Because we can do the same thing, and I mean, this is probably hurting your head a little bit, where we thought the distance or the amount of number of spots between 0 and 1 was pretty finite. Now we can see it's quite expansive. Because even with irrational numbers, say the square root of 2, because I can say the square root of 2 over 3, or the square root of 2 over 4, or the square root of 2 over 5. And we can make a whole bunch of decimal numbers there. But again, above and beyond. So this is all we'd have to do, is just use it as an inequality, because there's no real way for us to write it, especially if we talk about real numbers. The ones we can definitely list out are whole numbers, integers, natural numbers, our counting numbers. Because if we're wanting to go talk about the integers from negative 100 through 100, I got it right the third time on the first try. That's a conflict of statements. I said 1,000 the first 2 times. I still don't know where I got 1,000 from. But we can list these out, because the first one would be negative 100. Then the next one is negative 99, because we can say negative 100, negative 99, then negative 98, yes? And we can kind of see that there is a pattern in what we're doing, yes? Which means dot, 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 because we're saying it's going to continue to increase by 1 from one to the next. But this one has a definite endpoint, which is and that's it for today. Check to make sure. 132, it is officially 132.